Hi, welcome to Channels for Nextflow podcast. This is episode 39, going out on June 11th, 2024. As you might see, anyone who's watching a video, today is a bit of a special episode because instead of doing it online like usual, we're actually recording today's episode in person. So I'm stood here in Stockholm, in real life with Alvaro.
Thanks for the visit. Yeah, it's a pleasure to host you in our new headquarters here back in Forskaren. It's a pretty nice building inside, so we are going to give you a tour. We are Pixelgen Technologies. We are going to tell you everything about molecular pixelation and how we use NF Core for enabling our pipelines. So I am the Chief Data and Analysis Officer of the company, and I'm one of the co-founders. So I've been here from the very beginning. I can give you a good background of the company. And then I am joined with two of my excellent now friends of in this journey that has taken a lot of sweats and tears, but we are pretty happy about it.
Johan?
Yes, my name is Johan Dahlberg. I've been working here at Pixelgen Technologies for almost 2 years now, and I do kind of all things software related here at the company.
Great. I'm Florian.
I am Florian. I'm a consultant for BioLizard, and I've been working with Pixelgen for almost 2 years now. Also a software engineer, so working together with Johan.
Fantastic. I mean, you showed us around the labs a little bit before, and we kind of talked slightly about, we've got the kit boxes and everything. Once the sequencing's done, we've got the FASTQ files, presumably do some bioinformatics, but what is it that people use it for? What's it good for?
Yeah. So the product has a lot of applications. There are some of them that we still don't know. But what we demonstrate there has been recently an article that we have published, and what we demonstrate there is basically cell interaction, like what happens in the receptors of the cell when cells and cells communicate. So we do that by simulating that interaction. The second application that we demonstrate is drug development. So there is an antibody therapy that we use against cancer cells, and what happens in the receptors of the cell when you use that drug therapy. And then, or that biologic in this case. And then the third one that we demonstrate, which is pretty cool, it's cells under a chemotactic queue. And this is basically just chemicals in a plate and what happens in the cells, how they change the shape and how they change the receptors on the cell. So it is pretty cool.
And so take us. So I mean, presumably we start off in a lab with like a cell culture plate or something like that, and then some kind of antibody or some kind of binding process happens.
Yeah.
What take us through those steps?
So it's a very simple process in the lab. Cells get fixed. You want to take that snapshot of the receptors of the cell, and once they get fixed with a chemical that is mainly used in the lab, then we have a panel of 80 antibodies, and then they have like a small tail, a DNA tail, and you basically take those antibodies, stain your cells, and then once they get fixed after a while, then you have like several washes in the protocol. You wash, you do the first round of pixelation, and this is what is important, the DNA pixels, which is what gives the name to the company. Then they are copies, concatenars of different DNA identities. And those DNA identities get transferred into this construct. They get bound and to the tail of the antibody, and then they could position the antibodies in a zone. So you get this zonation of the cell, and then you remove that first zonation, and then it comes a second round of pixelation, and in that second round you connect the zones, and that's what is very interesting because you don't get only local relationship, but you can then piece them together locally in relation with each other across the cell. And it's a very elegant design when you think about it. Is it going to work? We're kind of like puzzling our minds, and it works.
So let me just repeat this back to you to make sure I understand. So we've got antibodies binding receptors on the outside of a cell. They've got DNA tails, and presumably by some kind of proximity ligation or something, there's kind of bits of DNA which are close to each other are basically being stuck together. And then there's a second round of sticking larger chunks of DNA together. And then by sequencing those concateners of DNA, you can infer the relationships of which antibodies were close to one another and in what three-dimensional organization.
Exactly. The concateners are unique. Then the size of the repeats are pretty big. That avoids clashes. And then also it is very important to know that this is kind of like, we often depict this picture of the city map or the GPS. It's some kind of like the pixels, when they are bound, they transfer a certain identity of a position. And the first one is the identity of the position. The second one is the identity of the connection.
Right.
So you can think of it in terms of like with this analogy with the city is that you have zip codes, recounting which antibodies live together in the zip code. That's like the first step. And then we have a second step where we connect, okay, these zip codes, they are sort of abstract. You don't know where they are based on just which number they are. So the next level kind of connects and say, okay, this neighborhood is close to this other neighborhood that's close to this one. Yeah. Sort of forming a network over the cell surface.
Yeah, makes sense. It's amazing. It sounds like one of those ideas that someone would dream up and you'd be like, it sounds good in theory, but in practice, really? Yeah. It's amazing.
Is that going to work?
It's very cool. So then, and you mentioned you had a paper, right? That was a Nature Methods?
Nature Methods. So it has been, I can show it here briefly. So it has been recently published. We've been working on it a lot. It has taken a long way. It has been one of those with really interesting reviews. I could quote reviewer 3 at some point.
That's trending on Twitter right now.
So if you're interested on the details, this is probably the best source to go, or when everything is really well explained and all the different details. We also have all the code for analysis and trying to make it really repeatable. And then also we have in our website, and we'll go through that later, we have all the data sets as well that we are publishing so people can go and dig into them. Also in the article, you will see what Johan and we just explained here, basically with that really nice pre-picture. This is actually one of the requests of the reviewers. Yeah. Max, our colleague, spent a lot of time doing that pretty picture. Yeah. It's really well explained. And then basically the second picture is making sure that things work. So we take like a couple of donors from the Karolinska Hospital actually. And then we make things that look interesting at the single cell. Like you can classify cells into different groups and cell types, and it makes sense. The proportions is repeatable. Then there are replicates there, the donors as well. You can integrate them, and things make sense. Yeah. So that was kind of like a control check to say that things work. And another one which is very interesting here is where the power of the technology is, which is at doing this type of polarity studies, how the receptors are going to relocate themselves when you are doing stimuli on the cell. And this is pretty interesting. So actually, you can look at two levels. You can look at the graph level, and then you can see this kind of like heat mappy sort of like, and then you can try to infer an unit sphere where you are distributing all the counts into the same sort of heat map, and it looks very microscopy like. So some people has been puzzled, some of our early customers as well has been puzzled about this. How can we reconstruct those kind of pictures? But in the end of the day, it's a representation. It's a representation that we choose from the data. We validate it also with microscopy, and those are the lower pictures as well. But obviously, microscopy has their disadvantages, which is, for instance, you are looking at it as a 2D flat image, and then you are looking at a certain amount. We are basically taking a picture of the 80 proteins on 3D at the same time.
I was going to ask you that. Did you say 80 proteins all at once? Yeah. I mean, you can't do that with a microscope either.
No, at the same time.
Easily.
You can spend a lot of hours in front of the microscope if you want.
Huge multiplexing. It's very cool.
Yeah.
And we can decide how we project this data. I mean, the graph data in itself is sort of an abstract entity, if you will. And then you create a layout from that graph, I think many people have seen those kind of graph layouts on
Right.
like something like a social network.
I was
for
going to
example,
say how people
clear.
are connected on Facebook.
Yeah, exactly, and that very clearly translates into some kind of 2D picture, while we are actually using this graph and presenting it in 3 dimensions, because that's sort of the dimension where it actually lives, right?
Yeah.
And then you can make a lot of sort of different choices on exactly how to do that. And for some purposes, for like visualization, it makes it clearer when you project it on a sphere, but you can also allow it to just stay in sort of some other type of 3D graph representation. So we can create these kind of representations. So what we're looking at now here is two different cells, one that has formed a Europod, and this is a little bit outside of my sort of comfort zone, but it's a kind of protrusions that cell creates when it wants to migrate across a surface and move around. And so to try to describe these things here, we're looking at 2 cells, one that's, if you're generous, it's roughly a sphere on the right, which is like a cell that has not formed this Europod, a control cell that we haven't stimulated. And on the left, we're looking at one that we have sort of chemically stimulated to try to start moving across the surface, and it's very clearly formed this protrusion, and it's also colored here by a marker that's sort of indicative of this protrusion, and that's one of the edges that the cell sort of moves when it's moving across the surface to create a locomotion.
It's very tempting to assume that this is an actual 3-dimensional model of a cell because it looks like it looks very convincing.
Exactly, and it has, I think one has to keep in mind when looking at these pictures is that like a visualization is useful even if it's abstract. So you shouldn't take this as like an actual image of the cell, but it's a way of visualizing and understanding the data that you're looking at. For me personally, at least, a lot of this is very nice, and especially nice when you're looking at it side by side with microscopy images, and you can see that you are seeing similar patterns. But I think a lot of the power of our technology lies in that we can then calculate all of these statistics directly on the graphs. So, which of course you can do with microscopy images, doing like image recognition and things like that, to translate an image into the kind of data that we sort of get natively, so to speak.
So, that was one. Sorry, was one thing I was going to ask you. This is single cell resolution, but how many single cells can you do in a single experiment?
In the current product, 1,000. But obviously, your experiments that you would plan like this one, you would plan more than 1,000 because you would plan like a control as well. And that's actually what we recommend. Like when you're stimulating cells, control rightly your experiments, sort of like take into account your time points, also in terms of sequencing, don't create any batches, in terms of flow cells and so on. And we'll have marketing materials in order to plan those experiments. But I think what is important is when you look at single cells, you are back on the microscopy wall. It's kind of like you are deferring again to the colors, you're deferring to understand this one by one. But I think where the power of our technology lies is about how to combine all these different 1,000 cells into some kind of measure that express what is going on in the biology, which is what we hope with our pipeline and our methods to push forward.
I'm going back to my PhD, but I've spent many hours in a dark room capturing images of single cells through the microscope and then trying to measure distances between fish spots and trying to just get any kind of statistics which would hold up. And it got to like a few hundred, and that was like a lot of effort. So to be able to do a few thousand in a single shot like this is amazing.
And I think one of the things to really highlight is like the multiplexing that you can do at the same time, because it's not only that you're getting like single snapshots of all 80, you get all of the 80 at the same time, which means that you can, so we tend to talk about 2 big spatial sort of statistics. One is polarity, which is a measurement of how clustered the proteins are on the cell surface, and that's calculated sort of per protein. But then we can also do co-localization of 2 proteins at the same time, and that in turn allow us to create these like co-localization networks to say how proteins might sort of create modules of co-localization across the cell surface. So
very cool. And with so many with so many such high multiplexing, you can presumably have a bit of a kind of discovery based rather than hypothesis based kind of experimental
Exactly,
model.
yes, yeah.
So many of these receptors in the Europe were described in different papers, but in a single experiment that we ran in a couple of weeks, we could recapitulate most of the literature that have been described.
So cool. Amazing.
This other video is telling a different story. So obviously this is more about the application of how cells interact, and by random chance, some cells when you happen to run the assay will be interacting, and we can discover those actually in our data. And in this case, in red is a B cell, and in green is a T cell, and they look actually like kissing each other. So they are in close interaction, and that's really cool to see also, because we hope that will facilitate certain type of studies.
So, I mean, that's taking an accident and making it a virtue. I mean, you're like you're a former 10x employee. Like I remember working with 10x single cell, and whenever you have like is it duplets or
Duplets.
Yeah, it'd be like a bit of a problem, because you can't really do much with that data. But here you're making it to a good thing. It's very cool. So I mean, one of the things I think is really interesting is, I mean, very often companies making kits for the lab, commercial companies working in kind of biotech, you have the lab kit you make and you've got all the IP around that, but also the bioinformatics and the analysis side is also considered very kind of tightly controlled IP. And, working in the NF core community, we've had plenty of conversations with different companies about running software and availability of software and Docker images and EULAs and all kinds of things. But I mean, your approach has been quite different to that. Tell us a little bit about how you work with open source.
Yeah. So first of all, I think that we are all, in a way, we are all open source developers. Like, we love many of the projects that are open source even coming out from companies, and we can tell you stories about things that we have found in companies that we have been collaborating with to help them support the community of open source. Like Johan has a clear example recently working with Microsoft in order to publish one of the libraries to use in our software. So I think it was like a very clear case for us in order to take that step. I think it's also, we are very disruptive in a way if you think about what we do, and it was a very disruptive attitude as well towards what other biotechs do, and say, why not? Why cannot you move the field through using open source and getting help? Why people should package something in a different repo instead of just trying to contribute it to your own repo? And then obviously we make our choices as well. Like when we started hiring people, and obviously Florian is really expert in Nextflow, so then doors started to open, and then this is kind of like where we piece together all the architecture that we have building in containers, in Nextflow and NF Core, and open source libraries as well.
That's amazing. And so the heart of the bioinformatics analysis is within that pipeline. You've got some open source software you've developed as well, right?
Yes, yeah. We believe that we will be successful if our customers are successful, and we believe that, I mean, we are targeting a scientific-minded audience, if you will, like researchers, but also, of course, like biotech and pharma companies, where you have a very sort of strong interest in sort of peeking under the hood and also in improving things. And we believe by sort of showing what we have and sort of working with the community to improve these things, everybody will eventually benefit from these things.
Exactly. So by being fully transparent, you lead to greater customer trust, and then therefore sell more of your commercial product.
Yeah, exactly. I mean that's in the end of the day what we are about as a company. But what I feel that I've seen during these years that I worked in this field is that a lot of companies also, they, as you say, they keep like a very proprietary software strategy. Often their success instead builds on top of open source packages that have been built in the academic space that sort of come in and replace those things. Then one thing that we do want to kind of make sure is that, okay, here's an open source foundation so that if you want to build something, you don't have to start from scratch. Like, we want to ensure that you, like other developers, could be as successful as possible on top of this, because it should only feed back into our selling more kits and having like a better product.
Yeah.
We are not reinventing the box. We don't have any box. We're just a reagents company,
Yeah.
and hopefully a software company as well. But we want to democratize those sort of experiments. Like, you don't need to buy a box in order to run your lab experiment. You don't need to use a very expensive software in order to process your data.
Yeah. Brilliant. So you've got the what's the name of the tool that actually runs the analysis? That's
Pixelator.
It's also Pixelator,
Yeah.
and that's open source on GitHub.
Yes.
And it's published to the Python package index, I guess.
Yes. Yeah.
Yeah. And then how does that work? That one runs in multiple steps, and you wrap the whole thing in a pipeline, or?
Yeah, more or less. I mean, it's like a Python-based CLI tool that has a number of different steps, and of course you can run it independently without any pipeline. You just string them together in the bash script. It works fine until a certain point.
I was going to say,
but of course, I mean, but what it gives us is this like very. I like to think of it as Lego bricks that you can kind of build whatever you want out of.
Yeah.
And it's also sort of modular then, so if somebody comes up with a better idea, better sort of strategy of doing a certain step or want to sort of branch out, it should be very easy to sort of do it in a Unix sort of tool philosophy style.
Exactly.
Like do one tool does one thing.
Yeah, and I can wedge something custom in the middle. And
Exactly. Yeah. And then of course, and why we're here today is that bash scripts only get you so far. The tool itself is not tied into any particular pipelining framework. It's sort of deconstructed, if you will, and you can pull it into anything that can run a command line tool, which should be pretty much everything.
So again, giving lots of options.
Yeah.
Doing it as an open source Python package is one thing. Building a pipeline around it is another thing. What was the final step, I guess, is doing it not just within Nextflow, but within NF Core? Like, what was the motivation for that?
I think it's mostly about leveraging the size of the NF Core community and creating visibility for the product that way.
Yeah.
We're following all the guidelines of NF Core because people work with these pipelines every day and they are familiar with the interface. So if we present the same interface, the same tools around it, it's much easier to get started.
Yeah. So basically, core sequencing labs will be running the RNA-seq pipeline or SAREC, and then so adding on a Pixelgen pipeline Pixelator pipeline is an easy extra step for them. That's for logic.
Yeah, and also reusing like the infrastructure configs for running in all kinds of different executors.
Yeah.
We can just reuse those, and you're ready to go.
Yeah, I think that credit to you and the community as well is that you have made it damn easy to use NF Core fact.
So Florian, tell us a little bit about how you came into this picture, because I mean, Alvaro, I remember talking to you about NF Core like years ago before any of this really sort of started off and your ambitions there. But tell us how this kind of partnership came about.
So I've been working at BioLizard on pipeline development, and there I've work a lot with Nextflow there for all kinds of companies.
So BioLizard is a consultancy firm?
Yeah, we're a bioinformatics consultancy firm, providing analysis, software support for all kinds of biotech companies, pharma companies, bespoke or tailored to whatever they want. Yeah, and so the idea of the tool with the subcommands and then putting it together in the Nextflow pipeline to do the orchestration, parallelization was already in place.
Okay.
And then I came on to do the implementation basically.
Right. And so had you worked with, you said BioLizard already does Nextflow consultancy. Have you worked with NF Core before that?
Yeah. We're trying to use NF Core as much as possible because of the same reasons we just discussed here. It's just so easy to piece something together from all the existing building blocks, the modules, and just following the guidelines, using the linting tools. It makes it all much easier.
Okay.
And we're also trying to bring that into companies, even if they keep their pipelines completely private when we're gone, and then they're stuck with this pipeline, and they need to maintain it, and maybe they have support contracts, maybe not, maybe someone else comes in. And if we just follow this structure, then it's so much easier for people to work on it. Yeah. It saves us time, it saves them time, it saves them money. So
I mean, the podcast that went out just, I think, is episode 37. it's actually only 2 days ago, but we're just recording a little bit ahead of time. But that was about the new NF Core and Eurofang manuscript, which has just gone out as a preprint. And one of my favourite figures in that is it's kind of like a bar chart showing, or a Gantt chart really, like showing how different contributors to the small RNA-seq pipeline change over time. And one of the key messages about the value of NF Core is exactly that because the pipelines are owned by the community, it's not owned by a single person or a single group, and if that person goes away, then someone else can come in and effectively take over, and it can change hands and is maintainable by a larger group of people over time.
So it's kind of like divided in two. The first one is just processing all the reads and building the molecules. That's kind of like what the first part is about, and finding the molecules that you are working with. And then the second part is forming the graph and then differentiating what is a cell. Until that moment it's called a component, and differentiating what components are cells or not, because there will be certain unformed cells or certain antibody aggregates that you want to get away with, and then it will be basically all the analysis that Johan was talking about getting polarity scores in every cell, getting colocalization values for every pair of proteins, and doing that really quickly and efficient also. And all the formats that are in the files that every step produces are also sort of like open formats. We don't have any private format. Actually, basically the pixel format that Johan invented is actually a zip file.
Okay.
No, we're just sort of bringing a bunch of different data frames together into this pixel file, so it gets like easy to move around.
You've been reading XKCD comics long enough to know.
The next standard, exactly.
So I mean, let's talk about how it started. I mean, we talked about the idea of having a pipeline a long time ago, and then Florian, you came on and started really building it. There's the experience of building a open source community based pipeline for a commercial company. I mean, this is kind of, you're the first company I know of to do it within NF Core, where there's a pipeline for your product by the company who makes the product. It's very cool. Was there anything that's made that process different? Like the first thing that springs to my mind is the fact that when we started talking about this, you were still in stealth. I mean, the name Pixelgen I think was public, but no one knew what you did. So like, how did that work?
Yeah, that was interesting. It was talking to a lot of people, and it has been sort of like probably, if I look backwards, smart choices along the line, because nothing was set up for us, and talking to the right people and bringing the right people on board as well, that helps you to create an architecture. And I think that's what we did in the beginning from these bash scripts that we talk about, like thinking about if we want the mass of bioinformaticians of the world, what do they program in? How can we package that programming language in Pixelator with all the intelligent stuff so people can use it in whatever architecture they are? How can we use that machinery in most of the computer centers in the world and put it all together into an orchestrated pipeline? So everything was kind of like when we relate to it, very logical, but when you're starting, it's not that logical. So this is something that I recommend everyone to think up front, like who is the community that you're leading, who are the persons in the future that you are going to hire, and where are going to be developing. And then in terms of how to manage the coming out of stealth, was a lot of piecing together with Florian in terms of how to manage, and with you, how to manage that privacy on your own private fork towards the public. And that actually, I have to give also credit to you both, that was managed really elegantly as well. Like, okay, now we have the fork, we bring it into NF Core, and then you create like a private fork that we can always sync. We have a branch within that fork that we plan the next development that we can push there, and then we have all the open source community development in the NF Core, sort of like. So I would say that in reality, as I picture it, together with Florian, we are developing a branch of Pixelator that NF-Core has, and then we bring new features in that
synchronize them over time.
in that synchronized way.
And so how did it work with reviews and all that kind of part of NF-Core?
So we basically had one big NF-Core review once the pipeline was like stabilized a bit. Of course, things were changing quickly, but at a certain point in time, just said, this is going to be it. And we just invited like NF-Core, the main contributors, some Sekira people in there in the private repository, and did the whole review just as the normal NF-Core pipeline reviews happen.
Yeah, so
just in the private fork.
So you still had the same pseudo PR or whatever it is we call it, the first release review, which everyone has to go through. You still had to do the same steps.
Yeah, of course. Yeah. And that was very helpful. A lot of like usability, maintainability things came up just to make it better. And once we implemented all these feedback and changes, we were basically ready to then transfer the ownership to the NF-Core organization. And then at that point in time, it became public. We could use like the NF-Core documentation infrastructure to show documentation and use all the like these Twitter notifications if you make releases and all this kind of infrastructure.
Yeah, exactly. You don't need to reinvent the wheel for all the deployment and. But is there anything in the pipeline which you found on a kind of technical level to be a bit different or interesting in terms of kind of writing the code for the Nextflow pipeline?
But the Nextflow pipeline is you can see it from like this metro map. It's very straightforward. You just cycle through the stages, and at the end you collect like inputs from all the different stages, generate a report, and that's it. So this was also purposely done. We wanted to keep the pipeline very simple. Most of the logic remains in the Pixelator tool, and the pipeline itself is basically to orchestrate in compute environments and run stuff in parallel.
Yeah, we also see it like as Florian said, with the simplicity in mind and respecting that, we see it into different levels. Like one of them is the intelligence of Pixelator, and that's also an open source. If you are trying to think of like a new algorithm or a new way of processing the data, maybe that's something that you want to put in Pixelator and encapsulate it into a tool, into one of these command tools, and then you can actually, there's a plugin infrastructure there, and then you can put a stage on top of that.
Brilliant.
But if there is a certain step that doesn't need Pixelator, if there is something out there that you're thinking that could benefit like a better filtration or a better algorithm to calculate the spatial statistics, maybe you want to think on putting like a state somewhere there in the pipeline, because I mean the formats are open source and very easy to check, so I think that contributing with an stage should be super simple by anyone in the community.
Yeah, that's really exciting because it's a totally new data type, and it's only been available to the world. It's kind of, it makes sense to start off with that everything is by you, but I think it would be really interesting to watch it evolve over as the years kind of go by and it becomes hopefully more mainstream.
And we just showed you the different graphs that we were plotting in 3D. We have no idea. We are not graph experts. We are starting to be now, but we have no idea about visualization and putting graphs in 3D. I'm sure that there are much better people out there. They can create tools there. They can go bananas if they want to do it much better than we do.
That's an invitation for anyone listening.
Yeah, for sure. Like, I mean, we want to be like come with good ideas, like challenge us on what we've done. I think that's just good, and that's what moves things forward. And I think for me, like personally, that all of these things are about like creating leverage. Like we're a small team. I think we have a very good team, but granted, we're still like a limited number of people, and I think that's shown to be like one of the main benefits of open source in bioinformatics and just in general is that you have more eyes on it. You have people who can sort of bring different perspectives in, bring different skill sets in, and that's when you really start like gaining a lot of traction on a fairly small team, sort of a core team.
Because I mean, like we used, for instance, a lot of like graph theory algorithms that we weren't any experts, so now we are starting to get some expertise and leverage, even if the team is also very timid to tell how good they are. But I'm sure that there are like graph theorists there that could say, okay, why are you crazy? Like you could do this shortest path algorithm that work much better.
I've got one more kind of thorny question for you because I think it's really interesting. The final thing I think is this relationship. You have a relationship with your customers, so you have to presumably have some kind of support system for your customers using the kits, but also using the bioinformatics, and then there'll be people coming into like the NF Core Slack presumably and kind of coming in through community channel. How do you manage those kind of support responsibilities? Do you have any different kind of tiers, or is everyone equal, or how does that work?
No, so in the company we have a very good, actually, I'm very small still, but super efficient support team, and they know about all these different channels. So you can contact them through, or contact us because we're all involved, through the normal sources like snail mail.
Does anyone do that? We're going to write a letter on my typewriter.
Plan Fida.
Send the fax.
Yeah.
And then obviously the community. So it's something that we watch over those channels as well, and we are always looking for improvements. But so right now it's a lot of like we describe it as a push moment, where we are pushing a lot of that content, and then we'll start to see at some point more of the pull moment. Okay, the community will start requesting through these channels that you're referring to. I want this, and I want this, and I want this, and definitely it's going to be a good collaboration because we have more or less nailed infrastructure about how to do these things and provide them.
Like you say, it's built on solid foundations. So yeah. And I mean, right, I think you started selling kits in September last year. Is that
September
right?
last year,
And
yeah.
so you've kind of
Our first kit shipped to Japan, which is crazy how you think of Japan of your first market in Sweden.
Yeah.
But don't tell me why it's shipped to Japan.
Whoever wants it. So I mean, it's been a few months. People presumably have now generated data, and you must have people starting to run the pipeline. Have you had any kind of feedback from customers or?
Very good feedback so far. At least I'm usually not in many customer calls, but from the team, from the support team especially, and even from Simon himself, the feedback is really good. I've been talking to some members as well of our early collaborators, and then they say that provided really good infrastructure and means to analyze the data. All the formats are very recognizable. The tools that we have created build on top of other open source tools, like our R package builds on top of Surat, and everybody is very happy. I think we need to understand what our customers want for the next step. Like we definitely do a lot of push now, but hopefully we will receive more pull from our customers saying, okay, this is what we want.
But you have no regrets at this point. People are able to run the Nextflow pipeline on their infrastructure.
Yeah, and I think that goes back a lot to what Florian was saying. Like, okay, when we work within this framework, a lot of institutions that I mean, they already have like the NF, like the Nextflow infrastructure, or even like the NF Core infrastructure sort of set up. So and since everything is containerized, I mean, instead of us like rolling something custom for ourselves, and then we would have to go out to every customer and like ask them, okay, tell us about your compute infrastructure. What can we do? You know, we need to work with everybody individually, more or less. We can say, okay, you probably have all of this set up already, and in that case, just go. And if not, it's like Nextflow and NF Core have been around for long enough that a lot of sort of the problematic areas in this field, like working with HPC infrastructure and things like that has already been set up. So okay, so you can interview them and ask like, okay, but what kind of scheduler do you have? Okay, that means that you use these settings, and I mean, it's relatively straightforward even to go to a customer and help them like set it up even if they don't have it already.
And presumably you can also there's lots of material out there, training material and documentation about Nextflow, and then of course you don't have to write everything yourself.
No, exactly.
And there's a lot of documentation about how to run pipelines in different containers. Like we use Docker internally, but some people will use Singularity, super easy.
Sounds like it's going well so far. What does the future hold?
As we showed, there is a lot of information in the structure of the graphs, and we are starting to explore that. Also, we have found some new interesting libraries that we can play with, and Johan has been doing a lot of work on that, on pushing the structure towards the pixel files, so the community can start exploring that data.
Nice.
Yeah, I think in terms of sort of functionality that is upcoming and that you can already try today, as you know, like Pixelator is being developed also in the open, so you can go in and you can see the changelog of everything that's like unreleased as of yet. We haven't quite finished it yet, but one major thing that is coming out is actually going to be a new stage, and it's going to be in the pipeline here eventually, and that's a new command that we're calling Pixelator Layout. And what that does is that it pre-computes these layouts that you can use to build the 3D visualizations of the cells. And having those pre-computed means like we have had them so that you can compute them for some time, but that means when they're pre-computed, your iteration time when you're working on making visualizations obviously becomes much faster, which I personally think is often, it's not just like an optimization for the sake of it, but it really kind of changes the way that you can work scientifically with the data, because if you can get instant feedback, look at things, not have to go out of the loop and wait for worst case a couple of minutes, like every time you do a new selection. I mean, you get out of the flow, but when it's fast, there's a lot of things coming with that, and that's what we're bringing now.
It makes sense. I mean, here we're kind of looking at the Nextflow pipelines, but we've just had the Nextflow Summit in Boston, which will have happened by the time this goes out, and now we've got this big focus exactly on moving beyond just that pipeline step. We've got data studios now where you can, in the same environment within the Secure platform, you can load up interactive kind of things, and also multi-QC now has got this refactoring where you can run multi-QC in scripts and in notebooks, and these visualizations, are they kind of Jupyter Notebook type thing, or is it custom software? Or?
Yes, you can run them anywhere you like, basically. So we pre-compute these coordinates, and then we will provide and we already show this on our tutorial pages today, how to visualize this using Plotly, for example. But I mean, anything that can plot these points can plot them, right? I mean, the main thing is like getting the coordinates. I love that idea that one day someone could run the pipeline, but then have like some kind of pre-configured tertiary analysis kind of container, which you could then launch in an interactive session to dive into that data. Yeah, exactly. It's clear that we are at an early stage still, and what I find very exciting about all of this is that okay, been here for 2 years almost now, and we can already do this. Like, I have no idea where we are in 2 years. And I find that wildly exciting. That is like so fascinating, and so much coming out sort of internally with us, but also what our customers are kind of finding.
What else is lurking in that data ready to be pulled out?
Exactly, yeah.
If anyone is listening who is in the same place you were a couple of years ago, kind of early stage biotech, thinking about how they want to architecture, what the foundations they want to lay, do you have any recommendations? I mean, obviously it sounds like you're happy with how it's worked, but I mean, what would you say to your former selves with the benefit of hindsight?
Yeah, I wouldn't reinvent the wheel, and probably I will go directly to the experts to talk. It took some rounds to find the right people, but if you want to be quick, and you can shorten and just find the experts and talk to the right people early on, and don't try to reinvent the wheel with really fancy solutions, because I mean, like we have been talking about these different infrastructures that it works really well. Most of the people use it for a reason, and there's a very strong community which took years to build. So it is, for me, I mean, I'm very happy, and I wish it could have gone faster, but I think there was some learnings in the end.
And like leveraging all of these nice things that are already in the open source, and whether like as a company, if you want to put that out there or not, it's a strategic decision. Depends on what kind of company you are trying to build and what kind of problems you are trying to solve. But I think, I mean, for us it's worked great so far. Hopefully that can serve as an example for others. But like the nice thing about coming in, and also if we kind of take a step back and like with the, once again, with sort of working with the Nextflow community and all of those things, it kind of gives you very much of a blueprint that you can follow, gets you into the right mindset, if you will, to build an application that is going to be scalable, that is going to be maintainable over time, that is going to have all of these properties that you like to have in your software application.
Alvaro, you will be talking at the Boston Summit, right, which is in like a couple of days. So anyone is already passed by the time people are listening to this. I'm sure it was a fantastic talk. But yeah, no, it should be on YouTube. We'll put the link to the video in the show notes, so you can kind of, anyone can go and catch up on that. And you'll be there again in Barcelona?
In Barcelona.
And Florian as well, or we hope.
Yeah. Hopefully the team will be in Barcelona, so you can catch with us up and make all the questions that you might have after this podcast, and then hopefully catch up with Florian as well. And we'll be super happy also to know what you have spare for Barcelona this year as well, how your products are evolving and the community as well with the things that you're pushing there.
That's right. Thank you so much, all of you, for making the time today. It's been an absolute pleasure. Really enjoy these podcasts, but it's particular fun today, to kind of doing a deep dive and talking about the intricacies of this process we've been through together. So it's been a real pleasure. So thanks very much for listening, everyone, and we'll see you in the next episode soon.
Thank you.
Thank you.